Question number 2. Separate samples of sodium carbonate and sodium hydrogen carbonate react with aqueous hydrochloric acid to produce the same products as shown in the table. Reaction 1. Sodium carbonate reacts with hydrochloric acid to produce sodium chloride, water and carbon dioxide. Enthalpy change del H1. Reaction 2. Sodium hydrogen carbonate reacts with hydrochloric acid to produce same product, sodium chloride, salt, water, carbon dioxide. Del H2 change in enthalpy plus 27.2 kilojoule per mole. Now A. Complete the reaction pathway diagram in figure 2.1 for reaction 2. And you see reaction 2 is delta is positive. So reaction 2 is endothermic reaction. This is the reactants. This is products. You know, in endothermic reaction, product has more energy than the reactants. Reactant has less energy, product has more energy. Product is the above than reactant in endothermic reaction. So this is the reactants given. This reaction will go this pathway, and this is the products. Product has more energy than the reactants. So product is sodium chloride, water and carbon dioxide. This is the product. And label the diagram to show the enthalpy change del H2 and activation energy EA. This is the EA. Activation energy means the energy difference between reactant and peak of the curve. This from this to this energy is known as activation energy. The energy difference between reactant and peak of the curve is known as activation energy. Next, B. The value of del H1 is determined by experiment using the following method. 50 centimeter cube, volume is 50 centimeter cube, 2 mole per dm cube hydrochloric acid. Hydrochloric acid volume is given, concentration is given, is added to a polystyrene cup. The initial temperature of the acid is recorded as 19.6. Initial temperature 19.6, and sodium carbonate mole 0.0400 mole of sodium carbonate is added, and the mixture is stirred. All the solid sodium carbonate dissolves, and the colorless solution is produced. The maximum temperature recorded during this reaction is 26.2 degrees centigrade. So here what is given? Volume of hydrochloric acid and concentration is given. Initial temperature is given, and this is the final temperature also given. Sodium carbonate mole is given. So you are asking, describe one other observation that shows that the reaction is complete. That means how you can understand the reaction is complete. Answer will be no more fizzing or no more bubbles, or fizzing stops, or effervescence stop, as hydrochloric acid reacts with sodium carbonate. So you know, any carbonate reacts with acid to produce salt plus carbon dioxide plus water. As carbon dioxide is formed, so fizzing occurs. When reaction will be complete, no more fizzing will be seen, mean fizzing stop. Next, number 2, calculate the value of del H1. Assume the specific heat capacity of the reaction mixture is the same as for water, means 4.18, and no heat is lost to the surrounding. show your working. So first of all, energy transfer Q or E equal mc del T. M is the mass of solution, C is the specific heat capacity, del T is the change in temperature. So M 50 by 1000, 50 gram. So divide by 1000, this is kilogram is converted to kilogram. 50 is given. Volume of solution is 50 centimeter cube, means 50 centimeter cube means 50 gram. 1 centimeter cube equal 1 gram. So 50 divided by 1000 times C 4.18, and you know this given 26.2 final temperature, 19.6 was initial temperature. So del T will be final temperature minus initial temperature. So if you calculate, you get 1379.4 kilojoule. Now you are asking calculate the del H1. Enthalpy change, del H1 means reaction 1. You see, when sodium carbonate reacts with hydrochloric acid, sodium chloride, water plus carbon dioxide is formed. Calculate the del H1, enthalpy change of the reaction. Now you see, energy transferred Q equal 1379.4 kilojoule. So del H1 enthalpy change will be change in energy divided by number of mole. I mean enthalpy change will be energy transferred divided by number of mole. Number of mole 0.04 mole is given. So you will get 34.485 kilojoule per mole, or you can write 34.5. Why minus sign? As you know, temperature is increasing, so this reaction is exothermic reaction. For exothermic reaction, delta H value is negative. That's why del H1 is minus 30.4 kilojoule per mole. Next, thermal decomposition occurs when sodium hydrogen carbonate is heated. Reaction 3, sodium hydrogen carbonate breakdown to form sodium carbonate, water and carbon dioxide. Calculate the enthalpy change for reaction 3. This means this reaction 3 using the data in table 2.1 and the value of del S1 calculated in B2. So you know this is the reaction 3 and this is the reaction 1. This is the reaction 2. Reaction 1 and 2 is given here. Reaction 1, reaction 2. So from reaction 2 and 1, how you will get reaction 3? If you multiply by reaction 2 by 2, then subtract 1, reaction 1, you will get this reaction 3. That means enthalpy of reaction 3 will be 2 times del H2, means enthalpy of reaction 2 minus del H1. This R2, reaction 2 times 2 minus R reaction 1, you will get enthalpy change of reaction 3. So 2 times del H2 value 27.2 is given, and del H1 you calculate here 35.4. So if you calculate, you will get plus 88.9 kilojoule per mole. This is the enthalpy of the reaction for reaction 3. This is the enthalpy of the reaction 3. See, Z is a salt that contains a period 4 element from group 2. When Z is heated, brown gas is formed. Identify the formula of Z and use it to write an equation for this reaction. This is group 2 calcium nitrate, period 4 you will get, this will be calcium nitrate, metal will be calcium. If you give heat calcium nitrate, group 2 nitrate, it will form group 2 oxide plus brown fumes of nitrogen dioxide plus oxygen. So that's why calcium carbonate decompose breakdown to form calcium oxide, brown fumes of nitrogen dioxide plus oxygen.